Hi, today we're going to be talking about subglacial topography. Subglacial topography is the mapping of the surface below glaciers. This helps to find a reason for the unprecedented glacial retreat, which is a concern for those who live in coastal settings. Today we're going to be talking about the background of subglacial topography and how it works. So students from the University of California at Irvine have been using data from NASA to create more accurate pictures and maps of the topography underneath glaciers in Greenland. The undersides of the glaciers in deeper valleys are exposed to warm, salty ocean water, while others are perched on sills and therefore protected from the warmer ocean water. They've been able to demonstrate unequivocally that glacial retreat in southeast Greenland is controlled by the topography of the bedrock underneath the ice and by ocean temperature. The students found glacial fjords hundreds of meters deeper than was previously estimated. They found just how large portions of the Greenland glacier were exposed to water either completely or by deep fjords underneath. It's crucial to understand the physical processes controlling the advancing retreats of these glaciers in order to improve the data given to coastal cities and communities about future projections of sea level rise, especially now with our warming climate. Until relatively recently, there was very little data on the ocean temperature near the glaciers and the water depth of the fjords. So many projections were inaccurate because this data was not accounted for. NASA has begun conducting their own studies about subglacial topography. NASA has a project called Oceans Melting Greenland, or the OMG project. OMG will help to improve estimates of sea level rise by discovering the extent that the oceans are melting Greenland's glaciers from beneath. OMG is going to do this by tracking changing water temperatures on the continental shelf surrounding Greenland and the reactions of marine glaciers to the presence of warm, salty Atlantic water. OMG will determine whether or not Atlantic water can reach into the long, narrow fjords of Greenland to interact with coastal glaciers. OMG will use NASA's G3 to fly the Glacier and Ice Surface Topography Interferometer, or the GLISTEN-A, in order to generate high-resolution, high-precision elevation measurements of Greenland's coastal glaciers. During the spring, annual surveys by GLISTEN will measure glacial thinning and retreat over time. A second aircraft campaign, also on the NASA G3, will occur each year in the summer to deploy 250 expendable temperature and salinity probes along the continental shelf to measure the volume and extent of warm, salty Atlantic water. The study in Greenland isn't the only study trying to figure out what subglacial topography looks like. Michal Petlicki also has conducted studies in the Antarctic. His work is a very simple method of inferring the subglacial topography based on repeated terrestrial laser scanning of the ice surface and inverse shallow ice approximation modeling. So he's using math to calculate the ice thickness with inverse SIA modeling in order to provide ice thickness estimation for the model validation purposes. The height of ice cliffs in regions of bare rock exposure was measured manually. Subglacial topography is simply calculated by subtracting the modeled ice thickness from the surface topography DAM obtained with the TLS survey. So how the mapping works is that scientists working off of air photos can assemble the topography for an area for DEMs. which are digital elevation models. That data can be combined with data for the area prior to glaciation, therefore showing the shape of the glacier from a profile. This allows scientists to see where the glacier is more likely to create grooves, which will then infiltrate warmer water. Another method of figuring out subglacial topography is using sonar. So, scientists can use sonar to detect the fjords from the coast because sonar will show the difference in density between the ice and the water in the fjords, and then into the density of the bedrock beneath. So, in summation, various mapping techniques have been proven crucial to discovering which areas of glaciers have meltwater running beneath them. This in turn shows where the accelerated melting is taking place, allowing scientists to more accurately predict sea level rise. And this is done either through sonar or through reverse mapping, telling the difference between previous and current elevation from bedrock and sea ice. Thank you.